All right, in this video, we will derive the Var of Par equations, and you'll see it's even easier than for second-order ODEs. There is no weird guessing involved whatsoever. And so once again, let's consider the system x prime equals ax plus f, where A is the matrix 7 minus 3, 8 minus 3, and f is the inhomogeneous term e to the 2t, 4e to the 2. And once again, the first step is to consider the homogeneous equation, a homogeneous solution, which we found. So we had to solve x prime equals ax, and we found two eigenvalues, lambda equals 1 with eigenvector 1, 2, and lambda equals 3 with eigenvector 3, 4. And we ultimately obtained that the homogeneous solution is C1 e to the t, 2e to the t, plus C2, 3e to the 3t, and then 4e to the 3t. And what was the idea of Var of Par? Of Par is to guess the same thing. So guess the particular solution based on the homogeneous solution. More precisely, xp of t is u of t times e to the t, 2e to the t, plus v of t times 3e to the 3t, and then 4e to the 3t. And just in terms of notation, this first vector, we'll call this x1 of t, and the second vector, we call this x2 of t. So in the end, xp of t, you'll see it makes stuff easier in the end, is u of t, x1 of t, plus v of t, x2 of t. And the idea is simply to plug in this formulation into the ODE. But before we get all lost in the calculation, you have to remember what x1 and x2 are. They are homogeneous solutions. So in particular, x1 and x2 solve x1 prime equals ax1 and x2 prime equals ax2, because they are homogeneous solutions. And once you understood that, the rest is just a matter of plugging in. So step 3, plug in xp into the ODE. So in this case, we just need to plug in xp into axp plus f, right? Because that's our differential equation, x prime equals ax plus f. And then remember, xp was u of t, x1 of t, plus v of t, x2 of t, and prime equals a u of t, x1 of t, plus v of t, x2 of t, plus our inhomogeneous term. Now here we have the derivative of a product, so we use a product rule. So u prime of t, x1 of t, plus u of t, x1 prime of t, plus v prime of t, x2 of t, plus v of t, x2 prime of t. Now this u and this v they're sort of like constant with respect to A. So they come out. So we have u of t, ax1 of t plus v of t, ax2 of t. I know it gets a bit complicated, plus f of t. Now, as complicated as this looks, there are actually a bunch of terms that cancel out. Because remember, I told you x1 prime is ax1, like right above. And x2 prime is ax2. So you can check, because those terms are equal, actually most of that thing cancels out. So this cancels out with this cancels out with this, and in the end, we're left with a much easier equation. Maybe let's do step 4. So we're left with the following: u prime of t, x1 of t, plus v prime of t, x2 of t, equals f of t. And now let's just write down what x1 and x2 are. So e to the t, and then 2e to the t times u prime of t, plus 3e to the 3t, 4e to the 3t, times v prime of t, equals to the inhomogeneous term, e to the 2t, 4e to the 2t. Which, if you write this in matrix form, precisely gives us our Var of Par equations. So homogeneous solution times u prime v prime equals inhomogeneous term. And then 4e to the 2. So those are the Var of Par equations. So you see, the cool thing is there was no guessing involved. We didn't have to set any terms to 0. We just started with our guess, u times x1 plus v times x2, and just plugged it into the ODE and had some simplification.